So this video will go through the first page of the review. So to start off, the definition of a derivative, I gave you two definitions in class. The first is the limit as h goes to 0 of f of x plus h minus f of x all over h, and then I gave you the alternate definition, which is the limit as x goes to a of f of x minus f of a all over x minus a. And you want to go in your notes if you want to see how the alternate definition, the one in red, gets used. It's also known as the difference quotient, which is really important if you remember. Not the quotient rule, difference quotient. And it's also known as the instantaneous rate of change. The average rate of change is not the same as the instantaneous. Average rate of change is the formula for slope. So this formula that I'm writing up is exactly the same as doing y2 minus y1 over x2 minus x1, which is not the same as the instantaneous rate of change. Instantaneous rate of change is the derivative. The average rate of change is, we would find the slope between the 2 points. So I'll write the formula first. And then I'm actually going to find the two values. So f of -1 would be negative 1 squared plus 2 times -1 minus 5, which would give us -1 minus 2 minus 5 gives us -8. And then f of 1 would be -1 whole thing squared plus 2 times 1 minus 5. And so we get -1 plus 2 minus 5, which gives us -4. All right. And so now I'm going to put the values back into the slope formula in orange. So the average rate of change, which is the same as slope, would be the y value at x equal to 1, which is -4, minus the y value at -1, which is -8, all over 1 plus 1. Those cancel, and we end up with 4 over 2, which is 2. All right, instantaneous rate of change, completely different question. Instantaneous rate of change is asking you, same exact question would be find the derivative at 1. So this is the same thing as f prime of x. So the derivative would be -2x plus 2. Therefore, the derivative at 1 would be -2 times 1 plus 2 gives us 0. Using the difference quotient, find the derivative. So this tells me that I will have to use the limit as h goes to 0 of f of 1 plus h minus f of 1 all over h. I also know, off to the side here, actually I won't even put it off to the side, I'll put it right here. I'm going to need f of 1 plus h. To find that, I'm going to take the function, and where you see those parentheses in red, I'm going to input now 1 plus h. So my next line, I'm going to square that inside, which gives us this, see, plus 2 plus 2h minus 5. So I get, I'm going to distribute my negative, so I'm going to make that positive and make all of these guys negative. So I end up with -h squared, -2h plus positive 2h, and then I get -1 plus 2 minus 5, and that should give me -4. Off to this side here, I'm going to need f of 1, which before we found was -4. And now, I'm going to actually do the derivative. There we go. So f primed of 1 would equal the limit as h goes to 0 of f of 1 plus h, which is -h squared minus 4, minus f of 1, which is -4, all over h. And we actually end up with the limit as h goes to 0 of -h squared over h, which is equal to the limit as h goes to 0 of -h. Now that it can't be simplified anymore, I substitute in 0. You get -0, which is the same thing as 0. So the derivative at 1 is 0, which we already got as an answer as a second part of part A. Moving on, find the equation of the tangent line. So for this problem here, I'm going to take the function and find the equation of the tangent line at x equal to 1. So what I did here was actually give you a picture of the graph. To do a tangent line, you're going to need a point at x equal to a, comma, the y value, which is f of a. Second thing you'll need is the slope, and we find that by taking the derivative and putting the a value into the function. And then part 3, you're just going to put it into the point-slope form of a line. Alright, so what I'm going to do is first just write out the 2 steps. So the point that we're using is 1 comma negative 4. I know that because we already did it in previous parts. I already know that f primed of 1 is 0. So when I substitute it in, I'm going to get y minus negative 4, which makes a plus, equals 0 times x minus 1. 0 times anything will cancel. So you actually end up with the equation y is equal to negative 4, which should make sense. That is the y value of the point. So over here, I believe somewhere, so I am going to create the tangent line in bright green, I guess. So I want to make it a little bit more accurate. So there's the tangent line. The reason why the equation looks funny is because tangent line is horizontal. How did we know it was horizontal? Because the slope here was 0. Now, if I'm asked to make the normal line equation, now I get this guy, which I'll do in yellow, coming down this way. And so the normal line is perpendicular to the tangent line. The tangent line was y equal to negative 4. If you tried to do the normal line for any other equation, you would do the opposite, which is the negative. Reciprocal is 1 over the slope at a times x minus the a value. And actually, I'll even write in f of a right here. So that's really what it would look like if I had a normal slope value of 1 or negative 2 or 5. The problem is because we have a slope of 0, it makes the normal line kind of funny. It makes the normal line vertical. And so a vertical line always has an x equals equation. And if you look at that line, it's going through x equal to negative 1. So that's the equation of the normal, which is perpendicular to y equals 4. Now, if you tried to put the point in and the slope in, we'd actually end up with this mess. And because of this is undefined, we can't use this method. Okay? Part E, find the value of x where you have a horizontal tangent line. So horizontal tangent line would be where your derivative is equal to 0. And remember, we want to solve this. Okay, solve. We're not going to use the difference quotient, so I'm going to do this the real easy way. The derivative would be negative 2x plus 2 using the rules equals 0. Solve, and I get x is equal to, and I'll solve it out for you, negative 2, x is equal to 1. So what did we just find? That f primed of 1 will give us a horizontal tangent, which means the slope is 0. We actually knew that already because we did that in parts A and B. So remember that for a horizontal tangent, this is the work that you're doing. So that's the end of page 1.